Hi, this is Chapter 5. We're on another important topic about precipitation processes. And it is basically going from a condensation nucleus all the way up to a typical raindrop. And you see that difference in size between the condensation nucleus, which is invisible, and a typical raindrop, which, of course, you know what that size is. There are two main theories that are involved in precipitation formation. We're going to be exploring both of them: collision and coalescence, and the ice crystal process. We reviewed these in a previous lecture, so I'm just going over them very quickly. Collision and coalescence, pretty easy to understand and intuitive. As the raindrops fall, they fall into other raindrops and aggregate them. And as a result of that, you get larger drops. And then when you add in an updraft that circles these back around inside the cloud, you can go through many rotations that can make larger and larger drops. Here's an idea from hail about the different updrafts that were seen by this raindrop, which became a big hailstone. The other precipitation process is the ice crystal process. And when we talk about the ice crystal process, we are effectively talking about the same water vapor pressure over ice and liquid that we described before. You know this chart real well, and this chart looks at temperature versus water vapor pressure for saturation vapor pressure. And in fact, when we really look into the chart here, we see that supercooled water, which is below freezing because it has no condensation nuclei in it to freeze off of, still has a higher vapor pressure at the same temperature relative to ice. So the liquid has more vapor over it, it has more vapor pressure over it, and as a result of that, we know that pressure seeks equilibrium. It goes from high pressure areas to low pressure areas, and we run into this kind of scenario. More vapor pressure leaves the water droplet, and more leaves the water droplet and grows the ice crystal as it moves. That ice crystal can go and form a larger ice crystal that becomes a snowflake. And here's where the two different processes move together. The collision hypothesis can move along with the ice crystal hypothesis, that as that ice crystal descends in the cloud, it picks up other ice droplets along the way, producing a snowflake in its wake. Here's a really nice idea of what snowflakes can actually become as they crystallize. And you can see from here that, yeah, this could probably be a conglomeration of ice crystals that have fallen and collided together. I hope this helps you out in knowing about precipitation processes. Next video is on precipitation types. Thanks.